All right. So let's move on to seventh grade because really seventh and eighth grade have even more to do with statistics. So seventh grade, we're moving on to this idea about that, okay, in sixth grade we learned that we need to describe things with variability using statistics. But now in seventh grade we move on to this idea of random sampling. And this is where I think the most, the general public maybe has the biggest misunderstanding about statistics. This idea about I can ask a small group of people selected randomly and make inferences about the entire population. I can ask a handful of students in my building and a big handful, a certain number of students, and that will tell me, if I can draw some conclusions about the entire school. And the big idea for seventh grade is this understanding that how to make a valid generalization. So, if we sample only people who ride public transportation, then that's going to skew us toward a certain segment of the population, maybe socioeconomically, or maybe even people who are more environmentally conscious, So this is a great standard to start to have kids really reason through the power of statistics. So the first standard there is really about this idea about, that we can sample a population and make inferences. The second standard is really about random sampling and what it is. And you can see there that this second standard is very action-oriented in terms of, my screen back, I'm not sure what's going on. So this idea that, and remember how we've talked about some of these standards give us almost explicit information about how to teach these. So, this idea that we're going to sample the same more than once to see how much variation there is and how much my predictions may be on target for that matter. So, I mean, that's a real power from the student's perspective in terms of, oh, wow, the more I sample, or if I sample and start to get the same results, I can start to say with confidence that I am, making an inference about the whole population. So that's a huge kind of conceptual understanding that students need. So let's move on, because there's a bunch for seventh grade. So then once we've started to get this idea that we can sample things, then in seventh grade, we need to really start to look at comparing two populations. And what's important is that students begin to see that we can look at measures of two different populations from samples and compare the entire two populations. And so it's kind of like this extension of the random sampling idea to start. And so, in seventh grade, we've got to make sure that we've got two kinds of data distributions that students can start to draw some conclusions about. And we'll look at a couple tabs here in a minute. And what's nice is, again, there's several websites where you can easily get data distributions to do this kind of analysis. And what's also interesting with this standard is you see that it's this idea about the intuition about two populations, that I'm going to think about, okay, so what do I think about, the overlap between two populations? What do I think about how much overlap? And then, once I perform the actual calculations, was my kind of informal assessment predictable or not, useful or not, close or not? So we'll look at a couple of tasks here in a minute that'll show that in action. So then number 4 here, we're getting into more of the kind of procedure-oriented standards. So we're going to use two populations, and you're going to use those measures of center and measures of variability that you learned in 6th grade. Here's the vertical coherence. You're going to use those measures to compare the two populations. So, you know, this gives the example, excuse me, this gives the example about comparing the length of words in science books. You could compare, you know, kids in different sports. You could compare different, you know, elderly population versus the 18 to 60 kind of thing. But the point here is that you're using those measures of center and those measures of spread to talk about the overall populations and to compare the two populations. And I think in the past, maybe we might have done some summary data for one population, but maybe not as much about comparing two populations. So that's an explicit big change for 7th grade. So then in 7th grade, we also then start this idea of probability formally. And so we talk about the likelihood of the event. Standard 5 there is just the whole conceptual understanding about how do we define probability. What does it mean to have 0 probability versus 1? And then where we get into kind of the more procedure-oriented for this area is in this number 6 and 7, where it's this idea of, you know, if I take more and more, if I collect more and more, they flip a coin 1,000 times, if I flip a coin 10,000 times, how does that help me see what the likelihood of getting a heads or a tails is? So, you know, you compare then, number 6 really deals with that idea about comparing the experimental probability to the theoretical probability. The next, number 7 there rather, is the idea, continuing the idea of the experimental versus the theoretical, but also making a judgment about, okay, if I have a, you know, if I throw a die that has 6 sides, but one side keeps coming up, maybe there's something wrong with the die. Why might there be a discrepancy? You know, so this first idea is, okay, so theoretically, what should my probability of getting a certain event be? So then, how do I compare that then to, you know, an actual experiment that I'm conducting? The whole idea in 7th grade then is, number 1, to define probability, which in the near future, you know, for the next several years, you probably, that will be something the kids will know coming to you, or they might just need a quick review. And then this whole idea about long-run data collection, you know, doing trial after trial after trial, and then also comparing that experimental and that theoretical possibility. Now, though you thought you were done in 7th grade, we keep going. And this is more than extending that understanding to compound events. So we're not just dealing with flipping a coin. We might be flipping a coin and rolling a dice. We might be pulling a card from a deck of cards and then doing something else. And so, you know, defining those probabilities for compound events, sample spaces, which is, you know, making your tree diagrams, your organized lists, your tables, whatever you need, and then defining all the possible outcomes, and then designing experiments, you know, to generate compound events. And really with this 8C, this would be a good place to look at some of the illustrated mathematics examples too, to give you a sense there beyond just that simple example about how you can use random number generators to simulate, you know, selecting randomly from a population. So this connects then directly to this idea about sampling. So the probability piece is written a specific instance of how how sampling can be used. Okay. So let's look at a couple.